case there's anyone who is unable to attend, or if you need to review it. I will post this on my YouTube channel that your instructor should have emailed out the link to. You should also have access to um, the review that I'm going through. And if you do not, you can email me. I'll give you access to the link because I don't have a copy of the link right in front of me. And I do have some questions here from Karen that I'll answer real quick. So for pints and quarts, you want to use the 480 ml and the 960. Um, I'm not sure where the 500 ml and 1000 ml are coming from. Meaning, not that you're thinking of anything incorrectly. It's just that um, where we have those numbers coming from are based off of cups, right? So one cup is 240 milliliters. Two cups is a pint. So two times 240 is 480. And then 2 pints is a quart. And so 480 times 2 is 960. So that's why we use those numbers. The 500, 1,000 are, I mean, you're real close to that number. It probably doesn't matter in the grand scheme of things. However, when we're trying to be very specific when it comes to nursing and healthcare and things like that, maybe that extra 20, 40 milliliters might be important. But I mean, in reality, that's really not a whole, that's like 2 tablespoons more or 4 tablespoons more of a particular substance. So it's probably not a big deal. But, anyways, but yeah, we want to use the 480 ml for pints and the 960 ml for quarts, not the 500 and the 1,000. Um, for the weight-based calculations, I'm looking right now at, and you can see the same thing I'm looking at. I don't see any weight-based calculations listed there. Um, I think that'll come in next semester, but I'll show you just in case, like what that looks like, because you can do it. It's not a big deal. Um, it's just an additional kind of like an additional step, and once you see it, it'll make sense and you know how to do it. And then as far as the IV therapy flow rate, yeah, there's flow rate questions. I'm going to talk about those. Primary and secondary, in all reality, all it means is that, let's say you have a primary infusion going on. Let's say it's just normal saline. So they're being infused with normal saline just for hydration purposes. And then they add what's called a piggyback, which is like a secondary IV bag that's also going to titrate into that. And really you would just calculate the infusion rate for the secondary bag separate from the primary. They don't even ask questions necessarily where they include both those things. You might see questions like that on ATI, where they try and trick you with some of these additional questions. But I'll show you the types of IV questions that they're likely to show you. Okay, so I think I answered most of your questions, and then I'm going to go through that here as well. So I'd say the biggest thing that is an addition to what you saw in 110 is the flow rate questions. Okay, because most everything you have done already. And so what I did here is I took your blueprint, and then I added a couple questions and built it from the blueprint. So that way you can see a couple questions of what they look like. And I'm going to kind of go through and tap on a few of these and try and answer a few questions. Make sure I address some of your questions if you have them. So if you do have a question while I'm going through, either just add it to the chat because I'll see it. You can add it as a direct message if you don't want to share it with everyone, or raise your hand. There should be a raise hand feature on your end of Zoom, and then I'll answer your question. If I'm in the middle of something, just be patient with your. I'll see that your hand's raised, um, and then we'll go from there. So some of this, like I said, is a repeat of some of the things you learned already in 110, like knowing what types of things are considered liquids versus solids, or you would think that soup and cocktail and pudding would be considered liquids, but they're technically solids because they're majority solid. They stay relatively solid at room temperature. It's probably a good way to kind of think about that. Um, the conversions you need to know as far as liquid household units, those are all listed here. Okay. So you have teaspoon, tablespoon, ounces, because 1 ounce is 30 milliliters. That's another way to kind of keep that in mind, like where they come up with that. So like the you know, eight ounces is a glass is 1 cup, right? So 8 times 30 is 240. So that's again what reinforces those numbers and why you don't want to use like the 300, the 500, or the 1,000. Those are just like um, you're rounding those up, and I don't think they want you to do that just yet, at least not here. You need to know your basic metric conversions, so like grams to milligrams, milligrams to micrograms, liters to milliliters, pounds to kilograms, pounds to ounces, maybe. Um, Maybe meters to centimeters to millimeters, and then your inches to centimeters. You just need to know those basic conversions, and then we'll answer some of the questions from there. So let's look at some of these questions. So these are pretty much your straightforward questions. I like to start with this first one here just because it's commonly missed, and and it's not for the reason what you think. So you're conditioned to round your numbers. So like when I do this, I get 0.375 grams. That is the answer. Do not round that to 0.38. Do not round that to 0.4. When you have your basic metric to metric conversions, you do not round those basic metric to metric conversions. You will round if you go into different units, like pounds to kilograms, you might need to round, and I'll show you that example in just a second. With this 12.5 micrograms, you're going to get something that looks like this: 0.0125 milligrams, and that is your answer. Do not round that. Do not forget your zeros here. That is the answer, and that's the answer you put on your test, and then you go on to the next thing. Okay. So I'm pointing those out just because I wanted to make sure you are paying attention to things you might have to or where you might be tempted to round. Don't round that. Same thing as if you get, like, let's say you get an answer that's like 1.275, let's say grams. That's your answer. Don't round that to 1.3. Leave that as your answer. Do not round. This one, though, if I take my 135 pounds, so I take 135 and I divide it by 2.2, I'm going to get 61.3636 repeating, right? So I do want to round this number. I do not want to round it to the nearest whole number. I want to round it to the nearest tenth. Now, the only reason you would deviate from that is if your instructor specifically told you, make sure you round to the nearest whole number. But from what I understand, you are supposed to be rounding to the nearest tenth for most of these things. So leave it at that. Okay. All right. I will come back to this. I feel like most students do pretty good with this. It's just a matter of manipulating the pints and the quarts and the ounces. Remember, you're responsible for knowing that you're looking for milliliters. So in nursing, we're always trying to work towards getting into the metric system. And so you want to make sure you are doing your milliliters, that you're calculating for milliliters when you do that. All right. So before I get into these flow rate questions, I want to start with one that's a little bit less intense. So there's a couple here. So I'm going to start with this one here. which says that the patients to receive 400 milliliters of Ringer's lactate over 5 hours. And we want to know what to set the infusion rate to. So with flow rates and with IVs, what we're looking for is some sort of volume over time. The volume that we typically deal with is milliliters, and the time is typically hours. You could also have cc's per hour. You could also have milliliters per minute. You can have, later on, we'll learn drops per minute. So we have a couple different ways to evaluate flow rate. Now, if they're just asking you to calculate an infusion rate, typically they're just asking you to give you to look for milliliters per hour. So even if they don't ask you directly, like if this question just said, what would you set the rate on the infusion pump to, and they didn't include the milliliters per hour, you need to know that they're looking for milliliters per hour. So like if you want to practice this where you can like kind of just ignore that this is here, just kind of block it out. You just need to know. So if they just ask the question here, like what do we set it to, and there's a question mark, you need to know you're looking for milliliters per hour here. This question is commonly missed because most students are looking for extra math to do, but really it's this: 400 milliliters over 5 hours, and then you just reduce it. So I'm going to take 400 divided by 5, and then my answer would just be 80 milliliters per hour. So I put a couple extra ones here. Like this one down here is basically the same question. I just rewrote it out so you can practice that one. These questions are in the Boyce 130 folder. That's where I got this from. So you can go through that. There should be a key listed in there as well. It might be as a PDF. But you can review the different ones. If there's writing on it, then that's typically the key, just in case there's some things that are blank. I don't have necessarily a separate key listed here. I just wanted to see if there's another one. You might get a question where they give you the flow rate information in minutes. So, but I'm still going to treat this the same way. I'm going to say I have 240 milliliters, 40 minutes. Now, again, when we're calculating flow rate, we don't want milliliters per minute. If when you're doing your rotations, you probably see like when a patient is on a IV, you probably see that the units are typically set at milliliters per hour. So that's what we're working towards, that standard. So all I'm going to do is convert minutes to hours. And then 240 times 60 divided by 40. And then I'm going to get 360 milliliters per hour. So we're just going to, you just need to practice these problems, getting used to what these look like. I don't know that you were introduced to this too much in the first semester, if at all. I know that the Allegheny campus isn't really introduced to these right away, which is why I'm introducing you to them now. And then I gave you some additional questions with that. Now let's talk about the next kind of iteration is, let's say I have an infusion running and I want to know how long a particular infusion will run for. And then like basically when to check it, when to replace it, or, when to, evaluate it otherwise. So in this particular question, it tells me that we have 250 milliliters of dextrose, 5% water. It's infusing at a rate of 100 milliliters per hour. And I want to know how long will it last. Now, usually when they ask you how long it'll last, they're usually asking you how many hours, how many minutes, and I'll show you the different ways that you might want to write this down just because some um, some instructors will want it a certain way. So what you're going to do is you're going to, or at least this is my strategy. You, as long as you're getting it the same answer as me, you're doing this right. I take the total volume, 250 milliliters, and then I multiply it by um, the infusion rate. But what I'm going to do is I'm going to get rid of milliliters and convert it to hours. So instead of it being 100 milliliters per hour, I'm going to put it as 1 hour per 100 milliliters. I'm just going to flip that. And the reason I'm doing that is because when I eliminate the milliliters here, I'll be left with a time when that's what I'm looking for. I want to know how long this will last for. So 250 divided by 100, and I'm going to get 2.5 hours. That could be one way that they want you to write it. Or you could say 2 hours, 30 minutes. I'm showing you both ways because I don't know necessarily how they want you to answer a particular question or if you'll even see this particular type of question, but it just gives you an idea of how to write it, okay? To get to your particular time. My assumption is you probably won't be asked that question because these are already challenging enough, just kind of calculating the flow rates. But if you do, now you know how to do it. These are technically everything that I've shown you so far is considered what we would call a primary IV flow rate calculation. Um, you you would also calculate a secondary IV flow rate calculation the exact same way. You would just be using it, it would just tell you that it's secondary or primary. Knowing that it's primary or secondary really doesn't change what you do from a math standpoint. Okay. Procedurally, it tells you what to do. Like you wouldn't hook the patient up to the secondary IV first and then the primary IV second. I think that probably me just saying that you probably rolled your eyes like, well, duh. But just as important just to think about. All right. The next couple of questions here are using drop factors. So I want to go through a couple of those as well because that is something you're going to see as well. So drop factors tell you that you're looking for a drop rate. When you are calculating a drop rate, you need two pieces of information. You need to know the flow rate and you need to know what's called the drop factor. Both of those will give you your drop rate. Flow rate is going to be milliliters per hour, but it could also be milliliters per minute. It could also be cc's per minute because cc and ml mean the same thing. Drop factor is drops per milliliter. So like later on, or if you get a question that just tells you the drop factor is 5, just know that that means 5 drops per milliliter. And drop rate is drops per minute. Now this does get a little bit confusing because um I was looking at questions earlier for some of the other semester classes, and what we were seeing was that you might have a question that's like calculate the drip rate for this heparin. Um, and then but what they're looking for is milliliters per hour. Now the reason I'm like kind of illustrating that and saying like, well, didn't you just tell us that drop rate is drops per minute? Yes, but technically you can still get a drop rate that's occurring without using a drop tubing. Okay. So these are specific types of drop tubing based things. So like you'll see this with something like morphine or something like that, where it's like kind of dripping in separately, or a nitroglycerin drip or something like that. And they want you to use some sort of like tubing where it's dropping in on a regular basis, but basically it's going to be the same level of diffusion that you would be getting in your IV. It just might happen a little bit more, or it look like it's happening a little bit quickly, even though it might take like 10 drops to equal 1 milliliter. That means 50 drops would be a teaspoon, right? Or 150 drops would be a tablespoon of this particular medication. So if they're getting like 30 drops an hour or 30 drops a minute, they're really just getting two tablespoons a minute, which seems like a lot, right? But that may only be infusing for like 30 minutes or whatever they tell you in there. This is more just getting you introduced to the idea of how to get there and how to use the information. Now, sometimes they'll tell you that you're using like micro tubing or something like that. You see this more with ATI, and they don't tell you the drop factor number, but they are looking for a drop rate. If they say micro tubing, the drop factor for that is 60 drops per milliliter. Okay. I don't know that you need to know that, but I figured I've seen that a couple times over the years that people have asked me about that, and that seems to be what they're referring to. All right. So to solve this question, I need to take the data that I have here. So I have 500 milliliters of dextrose 5% water. I have it infusing at 210 milliliters per hour, and I have a drop factor of 10. And then this particular question is asking me to calculate drops per minute, but I would assume that's what I was doing based off of having a drop factor. So what do I need to solve this question? I need to know the flow rate. That's 210 milliliters per hour. I need to know the drop factor, which is 10 drops per milliliter. And then I can get to my answer. What you'll notice is that in the math that I'm doing, I did not include the 500 milliliters. Okay. Why not? Well, the 500 milliliters does not affect our calculation in this particular question. If it said 500 milliliters over 25 minutes and did not give me a flow rate to begin with, at 210 milliliters per hour, then yeah, I would use that information. Okay. But I don't need it. I already have the flow rate. I don't need to do any additional calculations. I don't need to find out how many hours that's going to last for. I just need the 210 ml per hour. Okay. So if you ever get stuck with that, you will have questions going now from second, third, fourth semester where there'll be extra information. So they want you to be able to navigate that and figure out what to eliminate from the questions that are being asked to you, the extra pieces of information. Now, before I do this, I have to also, because my final answer is going to be in per minute, I need to convert that hour to minutes. So just make sure you account for that. The alternative way that I typically do this is I'll take the 210 ml if it's per hour, and I know what per 1 hour is 60 minutes. I'll just put 60 minutes on the bottom times the 10, and it just saves me a step in my math. But I'm going to get to the same answer no matter what. So I'm going to take 210 times 10 divided by 60, and I'm going to get 35 drops per minute. That'd be this. It's the same answer for both. If for some reason I got a decimal answer, like let's say it was 35.45 or 35.5 drops per minute, you cannot give a patient a partial drop. It has to be rounded to the nearest whole drop. So if it was 35.5, you would give them 36. If it was 35.4, sorry, you would give them 35 drops. You would just either round it up or keep it at that number, the number that it's at, the whole number. But your drop rate is always going to be at a whole number because you can't give somebody a partial drop. Okay. All right. There are some additional, like I said, additional practice questions. So I'm gonna leave those for you. That way you can practice them if you haven't done so already, just to make sure you have some additional practice. So I try to, even though I followed your template of like 4 questions, I try to like give you 2 of each type of question just so you have some additional practice, and then it gives me something to work on with you instead of saying, hey, this is what this is, um and then not having any other practice. Otherwise, you just following what I did. I want you to practice it on your own. Let's see here. All right. Here's a weight-based calculation that we can go through. So these are so your weight-based calculations are some of the 2-step calculations. So that does answer the question that Karen asked earlier on was, do we need to know dosage by weight? So yes, only because it fits into the 2-step type questions. And 2-step just means that you have to do more than one calculation to kind of get to your answer. So the two-step questions I have listed here are there's an ibuprofen question for a child, or there's 2 different ibuprofen questions for a child. So I'll work through the first one here, and then I'll save the second one for you to do on your own. So it says the MD writes an order of ibuprofen for 2.5 milligrams per kilogram. So that anytime you see that per kilogram, that's an indication that we are doing something with weight, patient's weight. Every 6 hours for a child, the child weighs 68 pounds. And the available is 35 milligrams per 2 ml. So even if it doesn't ask you how many milliliters will you administer, if it just says how much will you administer per dose, the fact that it is available in the 35 milligram per 2 ml, that's your indication to give that this is an oral liquid medication. Okay. So what I'm going to do first is I'm going to convert the patient's weight in pounds to kilograms. So I'm just going to divide by 2.2. So 68 divided by 2.2, and I'm going to get 30.909090. So we're just going to round that to 30.9 for the time being. I would not recommend rounding that right up to 31, even though it's 31. I would just make sure that you round to the nearest tenth just so you're following those directions. My assumption is that when you get your version of this question, it'll just be like it'll tell you 30 kilograms, or it'll tell you like it'll be more specific. But if I'm doing this, I'm thinking it's 31 kilograms. But we're gonna round to the nearest tenth. Once we have our kilograms, this is where we're going to do step 1, which is multiplying by the patient's weight, the 2.5 milligrams per kilogram body weight. So we cross that out. And then step 2 is converting the milligrams to milliliters. So the 35 milligrams and the 2 milliliters. And then we just solve. So if I take that 30.9 times 2.5 times 2, and then I divide all that by 35, I'm going to get 4.41. And since this is milliliters and it's greater than 1, I'm just going to do 4.4 milliliters. So that would be a sample of like what we would consider a 2-step question. Technically, this ends up being 3 steps, right? Because we have to convert pounds to kilograms, then kilograms to milligrams, and then milligrams to milliliters. So it is, but it's just one more step complication than your typical. You're ordered 100 milligrams, your available is 150 milligrams per milliliter. How much would you administer? That's what this question is. You know how to do the second part, since the first part's a little bit different. You'll have some insulin questions. You had these last semester, I believe. It's just a matter of reading the the chart. So if they tell you that the reading was 365, you look for the 365 reading. In this particular range, we would administer 10 units. So that way you're giving your patient insulin to absorb some of that glucose that they're taking in. And then you saw these last semester, or you probably even saw these same questions, the same reconstitution questions, but they're good to go over, like to just kind of review some of the things that you might see. So, how do you know you're dealing with a reconstitution? Well, one of the keys is if it tells you it's intramuscular, you know that you're solving for milliliters because it's being injected into the muscle, so it needs to be in a liquid form. If the label just tells you 1 gram and it doesn't say 1 gram per milliliter or something like that, then that's another indication that you're dealing with a reconstitution, which just means you have to look at the label to find out what the actual milliliters are. And so what you're going to do is you're going to read through this. It tells you for intramuscular use, add 2.5 milliliters sterile water, shake well. That'll give us a total volume of approximately 3 milliliters. And what we're looking for is right here. That 330 milligrams per milliliter is the indication that or that's what you're looking for. That's your concentration for solving this particular problem. Okay. Now, for next semester, you'll be doing some like pediatric dosages. So the normal or usual range will be important to know. So 250 to 1 gram, particularly for children. So if they're giving somebody like, 1,200 grams every 4 hours or 1,200 milligrams every 4 hours, that might be something you want to call the doctor about because it's going outside of the norm for what the label says to do. But you don't typically need to worry about that for these dosage questions unless they ask you, is this safe? Would you administer? But I don't think they're going to ask you that question. They'll ask you that next semester. Now we just take our order, 375 milligrams, and then we're going to convert the milligrams to milliliters. We're going to use the 330. And then, like I said, you've done this question before. This is just doing an injectable question. So 375 divided by 330. This is not new, and you're gonna get 1.136. So we're just gonna say for this particular order, 1.1 milliliters is what we're gonna administer to the patient. And then I'll let you practice the other reconstitution question. So those are the main like new stuff. I know I moved through kind of quickly, but I just wanted to kind of highlight the things that are important. Karen, I do appreciate your questions there, and hopefully I addressed those. Are there other questions, other question numbers you want to look at? Something that's not on here that I'm missing that you'd like to see reviewed? Go ahead.
You said there was some link we could go to practice, and then we could like turn it into you to check our work.
The key should already be there. So I mean, but you can review if there's something missing, you can email me. But the key for like this particular thing, like I think I keyed it all um on on the shared OneDrive folder link. Did you get the shared OneDrive folder link? It should have been on the same email that told you this Zoom link.
I'll have to look.
Okay, if you didn't, did you see my email in the chat?
Yes, I have
Yeah.
that.
Okay, just email me if you don't have it or if you're having difficulty finding it, and I'll email you where that is. But if you go to the link for the shared OneDrive folder, you go to the Boyce folder and then go to 130, you'll see a couple documents there that one of the, and they all say 25 spring because I'm just regurgitating the same review because nothing's changed. So you can just review that from from that. And there should be a key listed there.
Okay, thank you.
You're welcome. All right, so we still have like 10, 15 minutes. Are there any other questions? Total volume, absolutely. I assumed somebody was going to ask that question. Okay. So remember with the total volume, everything you're working towards is getting it to um milliliters. Yeah, the YouTube link will also be um is also listed in that same, like, what you should have received is the days and times that I'm reviewing with you, my YouTube link, as well as the OneDrive folder. So if you didn't, just email me and I will send you that information. Okay, yeah. I hope I'm right. The only thing I don't know is if your instructor passed along that information to you, but I passed it along to her. um, all right. So, did you have a specific question about the total volume, or do you just want to go through it? All right, let's just go through it just so we have, um, so we're all on the same page, just in case. All right. So, if they give you like a measurement for a glass and they don't tell you that the glass holds 8 ounces, um, that's not a fair question because I don't know about you guys, but at my house, I have glasses of all shapes and sizes. I have 12-ounce glasses, 16-ounce glasses, 4-ounce glasses. So we need to know what that is so that it should tell you. Okay. So one strategy that I found that some students do is they just convert everything to ounces and then multiply that number by 30, and get their milliliter count. That works. Or you can just do it as you kind of go along. So the first thing I'm going to do is just go through and look for everything that I'm going to be calculating that's considered liquid. Okay. So this is liquid. This is liquid. This is not liquid. That is liquid. Yes and yes. Okay. So everything but the turkey sandwich is liquid. You may not think jello is liquid, but if you've ever made jello, it's like a little bit of powder and a whole lot of water. So it is liquid, more so liquid than it is um uh a solid. So chocolate milk, ice cream, those kind of go along the lines. But like turkey sandwich, if we said pudding, if we said custard, these are all considered solids. Okay. So I was telling someone earlier, I said, think about like my kids get like those snack packs, like the pudding snack packs. They don't keep that in the, like, it's just in the, you know, it's not refrigerated. And so it stays solid at room temperature because it's pretty much a solid mixture of things. Custard probably falls into that same category. But if you leave Jello out, it will melt and it will become liquid. It might take a little bit more than room temperature, but this is Jello is liquid, pudding is solid. Um, you also saw like chunky soup. You also saw um, the fruit cocktail. This is more, there is liquid in chunky soup and fruit cocktail, but it's minimal. So that's why you just don't calculate it because it's going to be less than what the total volume there is. All right. So half a glass is 4 ounces. Yes, you do the calculation for the Jello. Absolutely. 10 ounces of coffee. So we have that. 2.5 ounces of the Jello. Half a pint. So what is half a pint? Half a pint is 1 cup, which is 8 ounces. Okay. I'm just putting everything into ounces right now just because that's a strategy to do. Half a quart is the same thing as 1 pint, which is the same thing as 16 ounces or 2 cups. Okay. So we're all I'm doing is trying to find a common thing. And what I decided on was putting them all into ounces. So what I'm going to do is I'm just going to add them all together, right? So I'm going to take my calculator. And I'm going to show you another way to do this if you don't like what I'm doing here. There's a couple different ways to do this. So I'm going to take 4 ounces plus 10 ounces plus 2.5 ounces plus 8 ounces plus 16 ounces. And I'm going to get a total of 40.5 ounces. I'm just going to write that over here. So 40.5 ounces. And what I'm going to do is I'm going to convert that because I know that 1 ounce is equal to 30 milliliters. So that 40.5 times 30 will give me 1,215 milliliters. That should be what our answer is. Or it is what the answer is. The other way I can do this is if I know that each ounce is 30 milliliters, I can just do those conversions as I go along. And I can get that as a thing. So like this is the one that's always tricky. 75 ounces, 240 ounces, or milliliters, sorry. And then 480. And then, so the alternative way is you could add up all the milliliters as well. So you can either add up all the ounces, multiply by 30, add up all the milliliters, and then you should get to the same answer. So there's no one wrong way. I think the tricky part, and I think you all would agree with me on this, is like knowing what not to calculate or what you should calculate, or if you get like ice chips. Remember, ice chips is half. So if they give you 8 ounces of ice chips, that's 4 ounces. Um, but that's how you would do this question. You're welcome. I hope that was helpful. All right. Yeah, any other questions? We still have a couple minutes here. I'm happy to go back and go through another or go through or re-go through one we've already done if that's what you want to do. I know most of you are just here to kind of just see what this is all about. Make sure you got all your steps right. Just so you all know, just as a reminder, your test is next week. So you have it like as soon as we get started. So just make sure you're prepared for it. It's not like 110 where it happened like week 7. This is happening week 1. They're gonna say, "Hey, how you doing? Nice to see you again. Here's your test." You get 25 questions. You can miss 2. If you miss 3 or more, then you're gonna have to remediate. You either remediate with the tutor. I think some of you see, um, oh, I can't remember her name. Her name's escaping me. You'll work with your tutor, or you can also work with me remotely if they allow you to do so, which they should. I don't think that's any problem. And for those of you that can make it, I will be reviewing this again. I'll probably cover some of the questions that I didn't cover this time around. I'll go through and I will um, probably I'll leave this as it is and I'll answer some of the questions I did not answer during this review. On the Thursday review, the Thursday review is from 11 to 11:50. And then if you do find out Yeah, same Zoom link. Yeah. Uh, I use the same Zoom link. All the links stay the same. So yeah, and you're welcome to attend both. I will, like I said, I'll post everything on YouTube as well. So if you can't come, and if you have a question and you can't come, you can always email me as well. And then I'll be happy to try and answer your question. A lot of times I can answer your question via email. All right. Well, if there's no other questions, we can we can wrap it up. But like I said, I'll be here for the next 5 minutes before I close out the session. So feel free to ask away. Otherwise, good luck on your test if I don't see you on Thursday. You're welcome.